All right. Hope you all are enjoying your lunch. As you continue to enjoy some food and some drink, we will welcome up our next presenter. It's my pleasure to introduce Neighbors Industries. We appreciate them as a sponsor of this event and helping us have this conversation. Neighbors is one of the largest in the world drillers there is. Certainly one of the things that they're known about. And one of the things that I want people to also take away is that they're one of the leaders in advancing technology in this space as well, through automation and other things. But today, Guillermo Sierra, Vice President of Strategic Initiatives and Energy Transition, is going to give us a little bit of their context in the geothermal market. And so please welcome Guillermo to talk to us for a little bit.
Hi, everybody. First of all, the Colorado School of Mines and EnerCom, thank you for hosting us. And for everybody here, thank you for sitting here and listening to me ramble about how we think about the world today for a few minutes. So we are a large drilling company. We operate in about 20 countries, and that means that positions have assets kind of around the world globally. We have spent an inordinate amount of time as a company, as an industry, really in the OFS space, figuring out how to solve complicated engineering problems, developing resulting technology, deploying a scale across the world to effectively help the hydrocarbon industry effectively grow to the levels we have so far. I think about it a little bit as that's who we are, that's what we do, but what I kind of want to be to some extent, and what we're trying to emulate, not trying to focus on particularly them, but in general, the reinvention of itself is a little bit like Netflix. It sounds kind of ridiculous, but if you think about it, we have had to come up with a better mousetrap to be able to compete in today's world. And that mousetrap is automation, is robotics, is hybrid systems, is inline power, is all these technologies and control systems that goes into our assets to effectively allow us just to compete, right? And that was, I don't know if you guys remember when Netflix started competing with Blockbuster, they used to get, that little DVD to your house. And that's just a better mousetrap that allowed them to basically exist in that world at that time. At some point, you start realizing that in the energy space, we have a bit of a problem, right? Because on the one hand, you have nuclear, solar, and wind providing about 10% of the global power need in the world, and that's just not enough, especially when the world runs on 20 terawatts of power today, and it used to be 10 terawatts of power 25 years ago, and 5 terawatts of power 50 years ago, and it'll probably be 40 to 50 terawatts of power in 25 years. Eventually, you realize that bridging that gap of going from 2 terawatts to effectively providing or trying to provide 40 terawatts of power in 40 years, from a clean renewable perspective, you've got to throw basically everything at the problem, right? So that's where we start using who we are today, that capacity to resolve engineering problems, to develop technology, the global engineering footprint, the manufacturing capabilities, the robotics engineering, the automation, all of who we are, we're trying to make energy transition investments into companies, ideas, concepts, and businesses that effectively can leverage our platform today to expand into what we need for the future. That's kind of what we've been trying to do. And if you think about Netflix, kind of going back to the idea of Netflix is, you got to invest in streaming. At some point, their concept of investing in streaming was paramount to their survival. Now, in today's world, right? Brian will hate me if I don't talk to you about the fact that we have these slides around talent, technology, and transition, which is important. We'll get back to it later. We have tried to get to this Netflix strategy of investing in energy transition by not only using our capabilities, our tools, whatever I described before, but from a capital or from a strategic structure. What we created is created a little, basically a new energy division, if you will, that is divided into 3 segments, right? The one hand, you have energy transition solutions, a business that we run internally where we're trying to decarbonize ourselves and our customers. We have made investments and internal investments in R&D and progress with respect to material sciences, with respect to hydrogen, with respect to carbon capture, hybridization of assets, energy storage, things that allow us to basically run more effectively, more efficiently, lower our emissions, and potentially provide commercial solutions to our customers to do the same. That's our solutions business. We, using the tools that I described before, have found that as we went through the processes, as we are going through the non-ending process of boiling the ocean, trying to find every single venture company out there in the world that is doing something exciting and disruptive in the space, we created a ventures group. And I'll talk a little bit about some of the geothermal, in a bit I'll talk about the geothermal investments that we've done in that space. Those are the ones that have been publicly announced. But within the ventures group, we have also, like I said, made some investments in hydrogen and carbon capture, and we have a pipeline of investments in the energy storage side, and emissions measuring and sensors and monitoring. Why? Because again, we feel like to some of those guys that are in the process of raising their seed round, the A round, the B round, whatever, they can use our platform, not only from the commercial side, from the financial side, from the engineering side. They can use our assets to pilot their, their business or their systems or whatever they're trying to do. They can use us as a customer, as a pilot customer. They can use us as an anchor to effectively try to grow. And when these guys are going through the decision-making process of, do I raise money through a strategic or with a strategic or along with a strategic that actually cares about my existence versus, more of a financially only driven investment, where the hope is, hey, I'll give you money, you keep kind of churning additional series, it's a higher valuation, at some point you're probably going to not plumb anymore, I get liquidity and I'm out, which is, look, we need the capital, we need that part of the world too, but we think we provide something a little bit different, right? Like not only we provide a little bit of capital, but we provide full dedicated support. We're trying not to follow the throw spaghetti at a wall kind of concept and invest like little money in a ton of companies and see where it takes us. We're trying to really be thoughtful of how we build this ecosystem and this portfolio of businesses. And hopefully really cool and exciting things coming up in the next year. So that's the venture side. And then finally, we have raised a SPAC, publicly traded. This SPAC is effectively meant to do the same that the ventures group does, just on a different scale, on a one-to-one basis, on a different scale for different platforms, but trying to find, if you think about, if I'm a company that wants to go public, not like the ventures group, if I'm a company that wants to go public, why would I go de-SPAC with a dude with $8 billion instead of with a company, right? And so we have the only corporate sponsor SPAC out there in energy transition. Obviously, our investment incentives are fully aligned with the underlying thesis of trying to create a portfolio of businesses that grows over time. We own a minority portion of businesses that we think are disruptive, that we create a synergistic and strategic relationship with over time. We think that can potentially look very exciting at some point. Yep, alignment is great. So, geothermal. One of the third and last pieces of the whole Netflix story that I had is, at some point, if you want to really lead, you got to invest in content. And to us, geothermal is a very thoughtful way of approaching that. We know, and I guess everybody here knows, that over the last 18 months, there've probably been more geothermal startups than the previous 10 years. We also know that, when we came up with horizontal drilling and all stuff to explore shale, things go very quickly. We got pretty good at drilling and automation and material sciences, and some of those developments really haven't made it to the geothermal market. We think that we can kind of help get there, but what we've done is we've created a little ecosystem or portfolio of companies. Again, non-overlapping portfolio of complementary technologies that we believe can change everything. Part of the reason I say that is, as everybody knows, the sun is 96 million miles away from here. And here we are with our solar panels trying to capture the light during the day and store the energy, convert it to chemical energy so we can keep it during the night. And like we were saying earlier in the other presentation I was hearing, a lot of minerals needed to be mined to store the amount of capacity necessary to do this on a dispatchable basis. And 10 miles down hole, there's a lot of power. I heard this statistic, like 0.2% of the heat under our feet can power humanity for about 2 million years, which is because it's too damn hot, it's too damn big. It's just as simple as that, right? And it's not, it's just a hole. It theoretically shouldn't be that hard. I know it is. But we're spending resources and time trying to figure it out and crack that out, because we think that to the extent that you can do so, you will get to a clean, baseload, renewable source of energy without the need for batteries, without the need to go mine stuff in the Congo, without need to go, process stuff in China, without really need to do much. If you can just poke a hole, effectively connect to the earth, and create power at a competitive price and value, then you can see solar and wind without the other elements that go along with it. It can be a pretty powerful answer to what the world needs today to bridge that massive gap. And look, again, fusion is in nuclear, nuclear in general is going to be needed. Like I said earlier, we're going to have to throw kind of everything that we got at this problem, because the problem is too big. We have too many people in the world and too much energy demand in the world that is becoming more mobile and distributed than it's ever been in history. So we're going to have to kind of throw the kitchen sink at this problem. We just feel like, probably a little bit easier to poke a hole deeper than develop nuclear fusion. Maybe I'm wrong. And so anyway, so what we've invested in so far doesn't mean that we're necessarily done. Let's see if I'm missing something interesting. We'll have these slides eventually. Okay, so these are the companies that we invested in. We like them because we think that they approach things a little bit differently, each one. And let me start with GeoX and Sage, if you have a minute, So we believe in the fact that if you're able to garner power from supercritical temperatures and fluids, you can increase the efficiency of such heat conversion materially. Therefore, if you're using water, as you know, the supercritical temperature of water, it's about 373 Celsius, you need to go really deep. And GeoX is built the turbo machinery necessary above ground, and also some of the designs to create wells that go very deep, and systems that go very deep and get to power through water stream and get to supercritical hot rock and effectively create power at these efficiencies, with the goal of eventually getting to $25 to $30 a megawatt hour, which I think is a fascinating goal to have. And as you know, humans normally get really good at anything that we practice. And so with time, you can see that at some point, these will continue to evolve and get us farther and farther, deep, lower and lower into the cost of electricity curve. So anyway, so that's GeoX. Materially disruptive, right? Like, if you think about a coal power plant, everything that you have from a steam engine, from the moment that you burn the coal and heat up some water and create steam to the electron, the entire infrastructure is there. So could you not see a world where GeoX is seeing a world, if you will, where you say, well, stop burning the coal and just make a few holes and repower the power plant, steam outside. So that would be fantastic, right? That's a materially disruptive utility scale geothermal 2.0 type of concept. Sage went about it a little bit differently. Sage is actually a fascinating company and the team is great. And what they do is they say, look, water sounds cool and all, but 373 Celsius, it means really deep and really hot, and it kind of melts everything. So there's a lot of things that need to happen before that's doable easier, if you will, than today. So how about we just start using conventional technologies and do it today, but instead of using water, why don't we use CO2? CO2 supercritical temperature is 31 Celsius. So maybe we don't have to go that deep. Maybe with a closed loop system and much shallower depths, you can get to the temperatures that you need to create, a cycle that produces electricity with supercriticals with CO2 versus water. And it's funny, the DOE actually spent hundreds of millions of dollars developing a ton of turbo machinery to turn supercritical CO2 into power. And they were really kind of doing it for concentrated solar or for nuclear for a long time. And Sage kind of put it together in their heads. They're like, can be done. The DOE did a lot of research. We can take some of that. And, we kind of can use conventional technology because we don't need to go that deep to get to those temperatures, 150 to 100 Celsius of heat around the area to get this, to get the system to work. The problem is CO2 is really corrosive and abrasive and it kind of destroys everything, right? So, one of the things that made Sage work was 3D printing, because 3D printing allowed them to go get a turbine printed out of titanium, which can turn 25,000 RPM and be small, and actually produce 3 megawatts per well, and not get destroyed through the CO2 that is going through it. So it's pretty fascinating, pretty novel approach. Obviously, this is, repowering a gigawatt power plant concept with Sage is not doable today. But their approach is, what I can do is I can make a hole with existing infrastructure, create a set of holes, and basically create a microgrid, right? Think about military applications. The guys over at the US Air Force has given Sage even a contract to go start looking into potentially powering Air Force bases with some of their technology independent of the grid. And if you think about critical infrastructure and our ability to deploy assets around the world, having that ability to be grid independent on demand without necessarily much work. I mean, make holes and create the system and all stuff, sure, but not something that you need breakthroughs in technology to accomplish. A lot of it has been done. It's just being put together now by the team. And then Quays, which is a little Star Wars project. So these guys effectively use a gyrotron to send millimeter waves through a pipe down hole and try to vaporize the rock at the bottom of the hole without melting it and without needing to get power down the hole. And so, this works. Their goal is to go 20 to 40 kilometers deep potentially, right? Like the capacity to garner heat that you can have if and when waste can work could be materially disruptive of energy markets. As you can see, by the way, a little bit kind of how Quays could potentially work with GeoX. You can see how this portfolio, this ecosystem, what we're trying to create, what we will create in different parts of the energy transition space, like I said earlier, potentially in energy storage, potentially in hydrogen, potentially in remote sensors. I want to create little ecosystems of companies that can support each other, because right now there's no point in competing. Right now we need to effectively continue to grow the space and continue to define the standards of technology that exist. And so that's kind of what we've done in geothermal. That's a little bit of what we've done in oh yeah, talking about the races. It's funny, we were talking a little bit earlier. One of the things that is hardest for these guys is going through the process of raising capital. And I'm convinced that having partners, strategic, doesn't have to be neighbors, but strategic partners can help startup companies validate some of their technology, right? Like, make it easier for the investor, the VC guy, to understand why is it that this is going to work or not. We think that we're uniquely positioned to diligence, understand, and validate technology. That's 5. And so we think that, using those skills, we gotta do a better job really as an industry of marrying up our resources with the more traditional financial investor into startups, which is the VC. We've seen that into our geothermal guys. I mean, we see some of them that are raising money like no other place, just closed Series A. And even though those guys are incredibly good at raising money, it takes time and effort. It takes so much time away from the guys, away from the garage, actually trying to do their job. And so we tried to help and bridge that gap. And I think if there's a message to be left to the group is we gotta get corporates to help bridge the gap and pay attention. And if oil goes to $120 and $130 and $150, it doesn't matter. It's gonna go back down. It doesn't matter. Ultimately, we can't take our eye off the ball on investing time, effort, and capital into these new technologies. Otherwise, we're just never gonna be like Netflix. So, anyway, thank you for listening to me, guys.
Yeah, well, thank you. It was a great presentation. We got to Star Wars investments, so that's a pretty big deal. We're going to take about 10 minutes here. Refill your drinks. Meet back here. We'll have presentations kicking off at 1:15. Thank you.